Okay. Hello, everyone. For those who don't know me, my name is Nola. I'm based at Tufts University, and I work on the A&H Academy Research Communities Initiative. Thank you all for joining us for this month's Research Roundtable. Um, I will give a brief introduction, and then I'll turn it over to Pete, who will present on his research and his work with the Soybean Innovation Lab. In the meantime, I invite you to turn on your camera if your internet connection allows and say hello in the chat box. You can introduce yourself, say where you're from, and if you have any research you'd like to give us a brief description of. For those of you who are new to the research communities, these roundtable sessions allow community members from the A&H Academy community to share their research and have conversations about successes, failures, learnings, goals. Anyone can present. We keep the barrier to entry really low, so there are only a few requirements. All that we ask is that you have a clear goal, that you offer a short description of the topic, and then save half of the presentation time for an open question and answer and discussion with other participants on the call. Some of our past presenters have shared their experiences from all over the world, including Ghana, Nigeria, Pakistan, Uganda, Vietnam, and lots of others. And so the work could be related to the global level, it could be related to a couple of countries or one country or one smaller area within a country as well. We have the two research communities. We have the food supply loss and waste community, and we have food access and demand for healthy diets. So between the two of them, we cover the whole range of the food system. If you'd ever like to present at an upcoming event, you can email me at researchcommunities@tufts.edu, and I'll put that in the chat momentarily. You can also write a blog, or if you'd like to reach out about any other questions, please do that as well. So today's session will have a presentation from Pete on tropical soybeans, and then it will be followed by a group discussion where you can ask questions, give feedback, relate to your own experiences, or anything else. So now that that introduction's out of the way, I will pass it over to Pete. Pete, thanks very much.
Yeah, thanks everyone. Just reset. Yeah, thanks the opportunity. Looking forward to this. This is great. I'm going to talk about tropical soybean and definitely trying to give some material through which you can analyze things through your lenses, your research lenses. So the talk will be 5-minute little modules, just to give you kind of the buffet approach to a topic and just give you a little taste of each, and then questions. As was mentioned, we'll just go 30 minutes and then questions, and so pick from any of these areas. So I'm doing an intro, background, of course. We'll focus a little bit on nutrition, touch on economics, touch on the soybean, the agronomy aspect of it, and then more of a macro view of basic, is it a big deal, little deal, its role in the African economy, and just a couple of final thoughts. My tropical, I've been tropical for many years. Started in South America as a Peace Corps volunteer right on the equator at sea level, so it was hot and sweaty in Ecuador, but I was not in the soybean space at that time. I was in the dairy industry and left that with milking cows and new cows, and so did large animal husbandry. This is a picture of me with started an AI, artificial insemination co-op, and brought artificial insemination, which was a new technology, to the region. The soybean part, I was a prop up at McGill University. I was still doing livestock, large animal husbandry up there, cattle, and so forth. Quebec is a livestock province. But when I came to Illinois, that's switched 180, and I was told in no uncertain terms that I needed to work on soybean and possibly corn, but soybean. Um, then I started my research really was somewhat in Illinois. I did that, but focused on Latin America. It was just the right time and started looking at Brazil and spent a dozen years as a consultant, researcher, teacher in tropical Brazil in the state of Mato Grosso, which is the largest soybean state in the world. Brazil is the largest producer of soybean in the world, moved from third to first position because of the state of Mato Grosso. So I just happened to be at the right time and cut my research teeth looking at soybean um, back at the turn of the century. Um, the That's what got me into the USAID world was when USAID came out in 2012 to visit with me and ask a fundamental question about they had seen the rise of the rural economies in South America on the back of soy, and they asked a simple but obviously deep question about whether that same soybean could be a development crop and have the same kind of impact in Africa. They were coming from a position, and as many of you are experienced, of history of working with native staples, and farmer productivity had languished. They were looking for new crops, certainly higher value crops, cut flowers, and so on and so forth. But they also wanted to understand soybean. They had not made an investment in soy before, and that started the Soybean Innovation Lab in 2013. At our peak, we were in 31 countries. We got the rug pulled January of last year when USAID was dismantled. We are still operating. We have no federal funding, but I can go into it, but it's not that, it's a big deal to us, but not for this talk. We are operating, have found additional funding from a variety of sources. So we're up and going, operating about 7 countries right now in sub-Saharan Africa. So the appropriateness, the simple answer to the USAID was, soybean, is it applicable to sub-Saharan Africa? Absolutely. That was easy. Agronomically, it's a slam dunk. Same soils, weather, season, but of course, the space, the political economy is quite different. And that's kind of the rub. How do you do it within the confines, the constructs of sub-Saharan Africa, which are quite different than South America? So that's where the research comes in, is the how to do this. So shifting into nutrition, the top 5 consumed crops in sub-Saharan Africa, cassava, maize, sorghum, yam, and rice, are high starch. It's just a function of the tropics that they don't naturally produce protein and oil in large quantities. So it's scarce between 20 north and 20 south, historically. So that's a gap. That's a big nutrition gap. And so this was part of the thesis of USAID, was if soybean could play a role, and that's really what happened in South America, that they had the gap too. Starting in the late 60s, they started doing the research, and they found that soybean did quite well. So soybean, about 38% protein, 20% oil, fat, and it's a nice complement to the starch diets and practices in industrial systems in sub-Saharan Africa. Very important is the digestible and dispensable amino acid score. And it used to be PDCAS, and soybeans always scored well. And this is proven both on the feed side for livestock. The maize soybean ration is highly digestible and high performance in livestock. Similarly for humans, it's a high quality protein. It scores well, and that's part of the story, an important story. We published a paper, just picking some pubs here. This was looking at protein fortification, the economics, but also the technical aspect of it in school lunch in Ghana, in northern Ghana, and we could talk about why that's difficult, even though technically fortifying it's a no-brainer. Very cost effective, but it's hard to pull off. Shifting now over to economics, and this is to help think about, well, why would USAID didn't understand soybean, but in working with them and helping them understand why it's a good idea to invest in soybean as a development crop. Not only is it a high quality protein and plentiful oil, which are scarce, but it is an industrial engine. And that's also, if you look through the economics lens at South America, North America, China, this industrial engine is really critical, not as well understood or thought of because it's not in your face with high levels of protein and so forth. But this is really its secret sauce, that we use economic industrial multipliers to understand various raw materials to see how they affect an economy. So conceptually, we think of when you drop any technology into a setting, a country, or a mineral, a raw material, whatever it is, how big is the splash? It's a rock in a pond. Is it a big splash, little splash? Does it really affect the economy a lot, or is it kind of marginal? And then we care about the ripples. Are they broad and affect lots of sectors in the economy, or is it very targeted and limited? And we'll spend some time on that. And how circular? How many industries? So not only how deeply are they affected, and so for soybean, it has a very high multiplier. Lots of industries like it, can use it. It's appropriate. So you don't have to buy sophisticated capital expense, engage in capital investment to utilize it. It can be simply crushed mechanically. I mean, it's very easy to work with. So very appropriate for the African setting, as it was in South America, as it was in the US when it flourished in the 50s and 60s. It was had a very fast adoption curve because the industrial properties were so good across a variety of sectors. So it's a great industrial engine. And that's important when you're thinking about development and when you're thinking about scale. It's kind of a theme of this talk is you want to have big impact here, affect, move lots of nutrients to lots of people and cost effectively. So we did some work on this. I had done the work in Illinois, I'd done the work in Mato Grosso, and so I had some familiarity, and we did a study in Malawi, just looking at the industrial multiplier of soybean within the Malawian economy. It has a very high, as we expected, a very high industrial multiplier. You can see wheat and barley are high, sorghum and millet because those are processed in country, wheat and barley for bread and maybe beer. I don't know if they do use, but definitely sorghum is used in beer. And tobacco Malawi's a very big tobacco country, but that's exported. It's dried, it's semi lightly processed. So they're not making cigarettes. Obviously there are issues there, but if we're just talking about industrial multipliers, they're not adding a lot of value in country to tobacco, where soybean you can and do. So value addition is important. It's readily usable by the industrial sector, so it's an appropriate technology. Job creation, definitely a different type of job, white collar job, youth job. So that's of value. And there's a strong price effect. You're putting capital in place. So that processing facility, it's an industrial system, has to buy ideally locally. So it draws locally, and you're not opening it one year when their prices are low and closing it when prices. No, you got to operate 365 every year. So it's very good for smallholder farmers. We looked at the top crops. I think this was 17 crops in Malawi, and just created this Latin square with impact multiplier on the vertical axis from high to low, and the size of the industry. Is it a big deal or little deal, going from right to small left, so that sorghum is relatively high, but yes, beer is consumed, but it's not a huge beer drinking country in Malawi. So the sweet spot is that northeast quadrant, where you have relatively large industries that also have relatively large multipliers. And so those would be for policymakers thinking about investment. And this is important because you want to be able to, you might wish that you could have more fruits and vegetable fruit canning and preparation and so forth, but there may not be the demand. Most fruit is directly consumed, not processed. And so you've got to decide whether you can actually pull it off from a policy perspective, not just because it's maybe higher value. Like cut flowers can be difficult for some countries. So that's the economic, little taste of economics. Now switch over to the ag part, the agronomy. The soils are acidic, so low quality, and people talk about soil sampling and poor soil. Yeah, that's a fact. That was a fact in South America. It's not material. You deal with it. It is not a barrier. It's not a choke point. They're acidic. If you can lime, that's great, but you can achieve high yields, profitable yields, even at low acidity level. I mean, not super low, but relatively low. And low organic matter. That's a fact. I mean, that's the tropics. So that's what Brazil proved to us, to the world, that everyone thought, the tropics, you can't grow anything. That's not true. That's not true. A feature of tropical soybean is that it has low or short photoperiod, meaning obviously on the equator, every day is 12 hours. That's for plants, that's short, because either, at 45 degrees north or south latitude, you're going to have 16 hours of sunlight, which is great for plant growth. Okay. And so you have to have adapted soybeans for short photoperiod, but we figured that out. I mean, we figured that out for South America. And so we knew how to do this. And then Africa is unique, is that it has elevation change. In the US or North America, in South America, where soybean are grown, elevation is not an issue. And elevation means cool nights, lower ambient temperatures and so forth. And, we're operating in the lower Shire Valley of Malawi at 100 meters and developing varieties down there. But I have a request from a guy in Kenya looking for varieties at 2,100 meters in Kenya, right? So that's a big difference for any plant and for soybean. And what's cool is you got 2 tons. We've done trials, 2 tons at 2,000 meters, and we got 2 tons at 100 meters. You just have to the right variety adapted. So it's a factor, but not a constraint. Seed management in the tropics is very, very important. And this is a big theme in the development world: seed system, lack of varieties, farmers not using the latest seed technologies, and so on and so forth. So this has been a thesis for forever. Seed has always been a problem, and what's the right seed policy, and so forth. So soybean is open pollinated. Open pollinated means that farmers can save seed from one year to the next. So you just go into a field, you grab some dried soybeans, you put them in your pocket. 6 months later, you plant them. You get the same plant, theoretically. And so saved seed is free seed, right? And so there's a lot of policy discussion. Certainly we can talk about that, about whether farmers should have subsidized or free seed. And that's generally the policy in the countries where we work. The problem with that is that there's no revenue back to breeding. So there's no revenue model there to breed and advance new technologies. And that helps explain why there are so few varieties released relatively, and why there's yield plateau. But so open pollinated as opposed to a hybrid where you have to go back every year for fresh seed, like in maize. So that's a real feature of tropical soybean. As I mentioned, it's sensitive to photoperiod. Tropics, as opposed to farming here in Illinois or in the US at higher latitudes, seed does not overwinter well. It's just too harsh. It's very hot, it's very dry, you get cracks, pests, all sorts of things. So seed conditioning, or the seed industry, is absolutely vital, a real choke point in tropical settings. For here in the US, you look at the seed industry, farmers were saving seed from day one. It's of course now illegal to do that, but you could. It's much gentler environment. The seed that is currently available outside South Africa is all non-GM. So we have established the only largest catalog of soybean varieties, commercial varieties, 400 varieties, and they're all non-GM. GM is not that material in terms of development and in terms of a development objective, or is that a constraint? Is that what's holding Africa and producers back now? It's good to have. It's a good technology, but that's not an issue in terms of agricultural productivity. A real challenge is soybean has to be planted at very high seed population. So if you're especially doing hand planting, which most everyone does, even commercial operations, one sec, um, commercial operations, bending over and planting 320,000 seeds per hectare is a big deal. That's hard. Farmers are used to planting 75,000, maybe 100. So this is non-trivial, non-trivial. Um, um, so the we published a paper called soybean. Essentially, it's a Faustian bargain. It's really profitable. It's a great crop. It works. There's no problem, except the bargain is it's a non-staple and it's management intensive. So you're asking farmers, especially farmers new to soybean, and soybean's new, to take a huge risk, take part of their land, put it into a non-staple. They have limited experience. And if they don't do it right, they don't plant high seed population. They don't plant narrow rows. They don't scout for rust. They've just wasted that land. So this is a real risk that the farmers bear. And so we spend a lot of time on de-risking soybean to assure and help them really respect that risk that planting a non-staple, especially a new crop, introduces. The policy somewhat conundrum or challenge for policymakers has been they want low input, they want low cost. And that's what this research that we published, we did three, these are crop budgets that are used just to compare the return to labor. And it's all labor in the traditional soybean system and agricultural system. Many of you are aware of that. It's all labor. But if you don't get yield, your return to labor and it's quite negative. It's not worth it for farmers to take the risk and shift into a higher value crop. They have to achieve higher levels of yield, of return to labor. And that's what that right-hand column, we show that without mechanization, just using high quality seed and good practice, you can really create sufficient and high levels of return to labor, essentially the wage rate paying you to grow soybean. But low input, and that's part of the bargain, the Faustian bargain. And we have a tagline within that we've used constantly. I was just talking to the guy who actually gave it. I met in Ghana many, many years ago. He wanted to know, what should a farmer do with $50? What do you do first? What don't you do? But you only have $50. And so that's what we have a thing called a smart farm. The technology platform lets the managers figure that out. What should they do? And that's the red bundle is high quality seed. Definitely is what you do with your first 50. You know that it germinates. And then do you have 15 more dollars a hectare? Take it up to 65. What would you do? And the managers figure that out on the smart farm. Generally, it's using inoculum, but I won't go into the technical weeds there. But you want to come up with what's the bundle you're going to hand to your smallholder farmers, and what credit are you going to extend, and what are you going to support? And so low return or low cost is not sustainable. It's not possible with soybean. And I'd argue it's not possible with staple systems as well. you'll just be in a cycle of poverty. Um, okay. Now, essentially the last section, just talk about what's going on at the more macro level on soybean. Since 2014, really since 2017, and this kind of, we could use this as the nameplate for SIL, it's really growing fast. It's working. It's working really well. Growth rate about 11%, compound annual growth rate since 2014, about 3 times the world average, fastest growing region in the world. Soybean is really taken off. This chart looks at the various countries, the leading countries. These are the top 2, 4, 6, 8. I threw in Kenya just as a because it's interesting, but the other 8 countries are the top 8. South Africa produces essentially half of Africa's soybean. Those are used internally. It's the most industrialized country, so it has a somewhat relatively high consumption per utilization per capita. But Nigeria is number 2. Trivia question that nobody gets is Benin is number 3. Benin's interesting. It's different from everyone else. That's actual consumption, not utilization. So there's a whole diet, cuisine at the household level of use of soy in Benin. Their usage rates, that 10 kgs per person per year, is actual consumption, not in some other processed form as a soy protein or animal feed or oil, something like that. So that's pretty cool. But the other countries are all it's industrial use, and that's why the levels are relatively low, because the size of the soy economy still is relatively small. You'd see 80 kgs or something per person in, say, the US or Brazil or something like that. Kenya is interesting. They grow a lot of maize in Kenya. There's been a lot of interest, and they import a lot of food oil. They only produce about 10% of their edible oil. This is a real policy problem for them. A lot of foreign exchange goes out. So they're aggressively looking at soybean. They have a large industrial sector relative to other countries. So there's great potential there in Kenya. This is a chart that looks at the top 30 crops planted in sub-Saharan Africa. They're arrayed from growth. So soybean is the #1 fastest growing crop in sub-Saharan Africa, about double the #2 crop, which is coffee. But it's coming from a low base. Less than 5 million hectares are planted, whereas maize at 45 million hectares. That tall bar, I don't know if you see my cursor, but you don't. Okay, I could use the pointer, but I didn't. 45 million, that tall bar, but its growth, it's coming from a tall base, so its growth rate is relatively small. Edible oil, this is important because one of the aspects walkaway is about fortification of oil. Sub-Saharan Africa, it's an oil market. That's what drives soybean, not like the US, which is a meal market. Palm oil still dominates relatively. It's getting smaller. Soybean is catching up, but it's catching up from way behind. Soybean, about 17% of edible oil is soybean, and about 50% is palm. And that's imported palm coming from Malaysia and Indonesia. From crop oil demand, the top oils demanded. Soybean is the top oil demander in terms of compound annual growth rate at 3.8% a year. And then the usual suspects of oil and sun, as well as palm. Um, so some final thoughts, and that's it. So why the difference between South America and Sub-Saharan Africa? Obviously, the soy economies are quite different. It has to do with land tenure. That's a big elephant in the room. That's a big deal. The land tenure system, and we can talk about that certainly. The soy opportunity related to land tenure it's a supply problem. It's not a demand problem. The processor, the industrial sector, is buying every soybean they can find. South Africa is desperate for soybean. Prices, we've looked at across a lot of countries, prices are the highest in the world in Africa for soybean. In Brazil, where I was working, they're the lowest in the world because they're furthest from the ocean. There are all sorts of reasons why. There's a lot of soybean there. So, and then leave you at the last point about thinking about policy and development policy and transforming the food chain and scale, having a high return on policy investment or research investment, affecting the most people with the least investment. So transforming that food chain, the real scale economies associated with soy. You move a lot of fatty acids and amino acids very efficiently. So that allows for protein fortification of school lunch, institutional markets, but also the private sector pulling a lot of protein through to consumers. And then oil. And you can think about on the back of oil. I don't know what the state of fortification is, just from anecdotally, I'd say very limited. But the potential may be there. So with that, I'll stop sharing. And thanks, everyone.
Thank you very much. That was fantastic. We'll open up to questions. So anyone who has a question, please go ahead and unmute yourself and you can directly ask the question. If you're unable to do that, you can type your question in the chat and we'll get it out of the chat.
I have a question. Anjali here. Can I go ahead? Yeah, okay. Thank you, Professor Peter, for that fantastic lecture. I have a very basic question, being a nutritionist, that around 25 grams of soya bean is allowed for consumption, and more than that is considered uncomfortable for digestion because of the digestive issues. So are you looking at soya bean and its value chain as a commercial product for protein? And when we are suggesting it for children and their schools, do we need to be careful?
Yeah. Yeah, great point. So a couple of things. One, and I can chat you or send you over to the work we did in Ghana on school lunch. We were using 5 and 10% fortification on school lunch for the reason you're talking about, both digestion, but also palatability. A little goes a long way. So point well taken about the limits. There are limits on how much you can fortify, but you don't actually need a whole lot to actually address stunting and protein malnutrition. But on the kind of on the advocacy side, SIL has always been demand-led. So we talk to the industrial clients, we talk to government policymakers about where they want to go. They come to us wanting to get into the soybean space, say school lunch. It was Ministry of Education in the case of Ghana. They wanted to do this. And then we know soy and we know the supply chain and how to do it and so on and so forth. And then we support them. There is not a lot of interest on soy for relatively for human nutrition. I think there's some donor interest in that, but other than Benin, it's just not consumed. It's not like soy milk. We did studies on soy milk, and I didn't put any of those studies up. Soy milk is a good one. School lunch, soy milk. You have what's called a soy cow. Great technology, works beautifully, but the cost is 80 cents a liter. I mean, it's not cheaper. I mean, it's obviously more nutritious than sugary beverages and so on and so forth. But people aren't switching. People don't have the resources to buy nutrition. They're not in that position. There are some household level technologies. The soy cow's commercial, and you're producing tofu. You're producing soy cheeses, obviously milk, yogurts. You do the whole bit. Works beautifully. There are some household technologies which work beautifully. Only cost $80 of equipment that you would purchase locally, so they're quite appropriate. But what's the demand for that, right? I think donors will, drop these technologies in and set up co-ops and do all sorts of things, and they're just not sustainable. There isn't a soy cow function. I mean, I can't find them. I mean, there have been hundreds, and we published a paper on this. I mean, it's a great technology, but you got to have the demand pull. So that's the challenge. So the oil story is a little more salient, and of course, the shift to meat consumption. Urban markets, they're great niche opportunities. There is more consumed and especially as I didn't put up the demographic trends, the urbanization going on, the shift to Africa being an urban economy really dominated. And soy will expand as people have soy lattes and so on and so forth. But we're talking about the food chain, the masses, then it's kind of a different story.
Thank you.
And others might have thoughts, but I did want to say a few things. First of all, thank you. This was just masterful, exactly the kind of thing that we were hoping to have in terms of an overview. And there are a few things that I wanted to probe a bit further on. One is the way in which every one of those linkages or multipliers is in effect a constraint if it's not there. And thinking about those different ripples, as you emphasized very much the oil industry, and then most recently talking about direct use of soy. But you didn't say that much, and just now you spoke a little bit about meat, but in the course of the talk and the framing, you didn't say very much about the importance of the poultry and dairy industries, where in Africa, of course, there's an enormous amount of pasture grazing, but intensifying poultry and dairy really does depend on this concentrate feed that soybean is this, exemplar ingredient to complement the low-cost cereals. So that's one question, is how is the Innovation Lab interacting with the poultry and the dairy industry and the seed and the feed producers, often complementary to the oil producers because they're using the cake for the protein. That's question number one, is about
I better remember
poultry and dairy as a crucial multiplier and also constraint. Question number two is that you briefly mentioned inoculants and the importance of the right strains of rhizobium to work in each setting. And I'm wondering about the degree to which the market for seed treatment is working well and people are getting the right seed treatments adapted to location. And then the third question is weed control.
Yeah.
So one of the key distinguishing features of African agriculture is the way in which so many things are chosen because they're able to outcompete weeds. And the weed pressure is just very, very strong. And soybeans, of course, are distinctively vulnerable to weeds. They're low, they don't successfully outcompete. And my understanding of the rise of tropical soybeans includes the factors you mentioned about photoperiod sensitivity, includes the aspects of soil management, includes mechanization of seeding to deal with the high seed rates that you mentioned, but also includes weed control, which I don't think you mentioned at all. So I was just curious about those three things. First of all, you could say a little more about dairy and poultry as a major consumer. Second, about rhizobium and seed treatments. And third, about weed control and how you're sort of seeing that in the African context.
Yeah, good, really good questions. The poultry, one of the things we do at SIL is focus on choke points, and that allows us to say we're not going to do this because it's not material to scale. It's all about. I mean, we were on the scale, and then we communicated that to USAID, and they love that. We're going to move the needle. So poultry and dairy, absolutely big demanders of meal, but that's not a choke point. There's plenty of meal if they want it, right? So because of the oil, right? So when you have, especially the rise of soybean, you've now got a lot more meal on the market, and finding a home for that, the crush margin, so it's really the value of those two co-products, is in the oil. And that's the scarce food stuff that policymakers have to deal with. And they need oil. And they don't want to, if you're Kenya, you're killing yourself because you're spending. East Africa, I did some earlier work, 3.5 billion in East Africa out just for oil, for food oil that should be used for much higher value goods. And so as a staple, you've got to have domestic policy to support cheap food oil, and that's not good. So that's where local production or access. So as soybean has expanded, the demand, the availability of meal is there. At the same time, the shift to meat is not near as fast as population growth and the demand for oil. So yes, and we're going to see it continue to rise. And that's, again, a good thing. If I were, if you could, take an option out on soybean, it would be a good thing that when you have urbanization, which is really soy strength because of you're eating more processed foods, you're time constrained, there are all sorts of demographic aspects there that favor soybean, and you increase your meat consumption as your income rises. So, but that's going on, absolutely going on, but that's not the salient point. The salient point is how to get food oil cheaper and more available, and take it out of the subsidy space, get local production. If you read the proposal that I just sent to the State Department, I didn't really talk about local production because they don't want local production. But it's doable, and that's the story of, Brazil is exporting from 1,500 kilometers inland and making markets in wherever in Europe or in Africa, in Asia, so that it has. So anyway, that's the poultry, dairy, and the inoculum we thought when we started, we had a soils guy, we were doing a lot of it, and then it's not salient. The commercial sector is there, the inoculants are there, they're viable, there are multiple players. So we run what's called the Pan-African trial. So we're sending out, we've done 31 countries, 9 years, over 240 locations, 40 varieties, 50 varieties. I mean, just large quantities of seed packs for clients who want to figure out what variety works best for them, all with inoculant, no problem. And that could be mixed and match. We happen to have fine-tuned things, and we have a central location in Zambia, and it was a problem, and SIL didn't solve that problem, but we realized, we tapped out and said, wait, the NARs are producing inoculum, which is, it's a low-tech process. IITA is producing inoculum. Private sector is producing inoculum. It's not an issue. And sometimes it's not always necessary. Like in the rest of the world, it's not like it's Liebig's law doesn't always apply on inoculum. You have to run the smart farm and figure out whether and it's cheap. It's $15 a hectare, so it's not a big deal. Weed control is a good one. One of the interesting things about the Brazilian experience is, Roundup is good. And, I was there when Roundup was the thing, right? But it was far from sufficient. So that Monsanto, we can play that game of who the bad guys are. Monsanto was in a much weaker power position with respect to tropical farmers than they were with temperate farmers, because Roundup was a miracle. Weed pressure, not that great, was a miracle for high labor costs. Illinois, in Brazil, geez, I got bugs, I got fungi. I mean, I got a storm of problems. Weeds, yeah. Can you tank mix something for me? How much can you stack? And they couldn't stack, and they still haven't stacked. So you got to spread. You got to have some control. So the demand, the power of the multinationals was in the soybean world was not as their market power was less, but their technologies just weren't as effective. So that comes back to chem, so we work with BASF, with Bayer, with all the chem suppliers. Those technologies are available. Tank spraying, those issues are bad, right? I mean, from a health standpoint, environmental standpoint, getting stuff sprayed is not not trivial. That's a big deal. That's why 320,000 seeds is so critical. Soybean is a canopy crop. That's what, I don't know how well people know it, but that's what's going on here. Brazil, that canopy closes and weeds stop. But you're asking someone to plant a 50-centimeter row now. I mean, 320,000 every 5 centimeters. I mean, that's a lot. So we've developed some MAC solutions and a planter and so on and so forth. But even without mechanization, weed control. We have courses, training, and so forth on not only weed management, but uh, um, pest management, and so on and so forth. We have the best, just a great guy. He's trained here. He's um, based in Nairobi. Haroon is the best pathologist, and we work him to death. And we're agnostic. We're working. We had a slide yesterday that we had a staff meeting yesterday, and Haroon, Dr. Marithi, presented this slide. He's down in Malawi right at the moment with some clients of ours, and he has a slide of a Pan-African trial in the lower Shiri, so southern Malawi. And when you do a trial, you're doing 40, 50 varieties. So if you did a drone shot, it would look like grandma's quilt, high, low, different shaped leaves, all sorts of things going on. This one is grandma's quilt because some varieties are affected by rust, others are not. We've been working with IITA. This is something and trying to figure this out. Rust resistance. With rust resistance, now you don't have to spray. You don't have the smallholder problem because smallholders aren't going to go out and tank spray 3-4 times once even. But tank spraying is not a sustainable solution. Backpack spraying is not a sustainable solution for a relatively low value crop like soybean. Maybe a high value cut flowers. I don't know where fruits and veg, maybe I don't know. But for soybean, it's just not going to get done. So canopy is critical. Rust resistance is a great feature of it as a technology for smallholders because it's in every variety per se, and they don't have to worry about rust, which is a devastating disease. It's really the only one that that will take you out, will take out 80%, and it'll be real. I mean, it's not every year, so and once you see it, it's too late. You've got to scout early, and we've developed a whole rust management plan appropriate for outgrowers, for nucleus farms who have large outgrower networks and so forth. So it's enough on weed control, but it's you're right. The pressure's frenetic. I mean, so you've got to think of appropriate. And this is this Faustian bargain. You want that productivity. You got to get out of the staple crop, wide row, low productive, low return to labor. How do you get out of that? You got to intensify. It's management intensive. So how, we can talk about that as well, about management systems and I was just on a call with a client in Eastern Cape in South Africa, just talking to them. They want to get into soybean and with their 6,000 outgrowers. And it's really about that last mile of how they engage their smallholders, because you don't hand a farmer here a bundle. They got more resources and consultants. I mean, they're not independent, and African farmers shouldn't be independent either. They need support to help de-risk the crop. They need management support.
Fascinating. Thank you. Thank you. I see we're at the hour, actually. Wow.
Yeah.
That was actually a great point to conclude on.
Yeah.
So thank you very much for the
Sure.
presentation, for answering the questions. I think that was really
Sure.
terrific and
Yeah,
great
perfect.
overview.